Hey guys, it's Mr. Knockme here, bringing you another lesson for your math class today. Today we're going to be going over solving linear systems by graphing, and in order for us to do that, I'm going to assume that you already know how to graph lines in slope-intercept form. It's going to help you out to do these types of problems since we're going to be solving by graphing. Before I actually get into it, I do want to discuss one thing. When you graph a line, I want you to understand that this line actually has some importance to it. It's not just a random line that was asked to you to graph, right? So what this line represents is infinitely many points on a XY coordinate plane, right? And on these points are ordered pairs. So for example, this point right here would have an ordered pair of 6, 5, right? And this over here would be 3, 3, and so on and so forth. This one right here would be 0, 1. And there's even infinitely many points in between each of these points, right? So many that I can't count them all. And what you need to understand is each one of these points is a solution for the original equation that you graphed. Meaning if I were to take any one of those points, plug in the x value and plug in the y value into the original equation, I will get a statement that is true. It is a solution that will work for that equation. So in essence, the line that you're drawing is infinitely many solutions to your equation, right? It's a list of all of them. So it's a nice representation without you having to write down every single possible combination. Okay? Now keep that in mind when we move on over here. So that was just one linear equation. What makes something a system is when we have more than one. You have 2 equations, 3 equations, 4 equations, and so on and so forth. It all depends on how difficult your teacher wants to make the problem for you. We're going to start off with something easy though here with just 2 equations on this system of equations. When I have multiple equations, I like to color code my equations and also number them so I know which equation I'm talking about, not this one or that one. I'm going to call the first one equation number 1, and I'll call the second one equation number 2. Okay? Equation number 1 is already in slope-intercept form for us. So we can go ahead and graph this one, right? Our slope is 2 over 1, and our y-intercept is -2. So we're going to go ahead and graph this, going down to -2 and making a dot. And it has a it has a slope of +2 over 1. So I'm going to go up 2 and to the right 1. I'm going to draw this a few times just to help me make sure my graph is super accurate. So I'm going to go ahead and draw my line here. It's going up forever this way, and all of these points that I'm drawing along the way are just solutions to my equation. And beautiful, right? So that right there is a representation of all possible ordered pairs that I can plug in to my equation 1 for it to be true. Now, I'm going to go ahead and work on equation number 2 right here, which is not in slope-intercept form. I'm going to go ahead and convert it. First, I'm going to rewrite it as 3y plus 6x equals 18. And I'm going to go ahead and subtract the 6x over to the other side. You end up with -6x plus 18. Divide both sides by 3. And you end up with y is equal to -2x plus 6. Right? So you have over here a y-intercept of 6 and a slope of -2 over 1, right? So I'm going to go over here and graph my y-intercept, which is 6. 1, 2, 3, 4, 5, 6. Count that out, right? 1, 2, 3, 4, 5, 6. And it has a slope of -2 over 1, meaning I go down 2 and to the right 1, right? And I'm going to go ahead and draw my line right here. Hopefully I can get it to be at the right spots. Kind of fell off at the end there. But take a look here. The 2 lines cross each other at exactly 1 point. And if you remember earlier, I was telling you that each of these lines represents solutions for their respected equations. So the red line is solutions for equation 2. The blue line is solutions for equation number 1. What's nice is you see the 2 lines cross at a given point right here. This point is 2, 2. What this says is that point 2, 2 is a solution that works for not only the red line, but it also works for the blue line. And that's all you're looking for when you're solving system of equations. You're just looking for a solution that works for both equations, right? Check this out. You can actually take that point, plug it into both of them to check. So let's go ahead and check our work here. Check our work. So I'm going to go ahead with equation number 1. I'm going to plug in the values for y is equal to 2 times x minus 2, where our x value is 2 and our y value is 2. I just realized this is probably not the best example with a bunch of 2's. But I'm going to go for it anyways. So I have here 2. Does that equal to 2 times 2 minus 2? You know what? I'm going to highlight this because this is a little confusing. This 2 right here comes from the y value from the point that we just found out. And this 2 over here in the parentheses is coming from the x value that we just found out where they cross. Hopefully that helps you out there. Simplify this out. Does 2 equal to 4 minus 2? And it does. So equation number 1, it works for 2 comma 2. The same point needs to work for the second equation. I'm going to go ahead and write this out. Equation number 2 is 3y plus 6x equals 18, right? Plug in, again, 2 and the 2 for your y and your x. So I have here 3 times 2 plus 6 times 2. Does that equal to 18? I'm going to go ahead and highlight this as well just so you understand that this 2 right here is coming from the y value and this 2 right here is coming from the x value. Go ahead and simplify and see that this actually is a true statement thanks to these 2 points right thanks to this pair right here. So you end up with 6 plus 12. It does equal to 18. So the answer for this system of equations is the ordered pair 2 comma 2. 2 comma 2. And that's it, guys. You basically just have to graph the 2 lines and see where they cross. The only thing is you got to make sure that your graph is accurate and you use a straight edge. Try to do it on graph paper. If you end up getting points that are in between, it's going to be hard to read. Okay? Now, there are special scenarios on these types of problems. I'm going to talk about one of them right here now. One scenario is, let's go ahead and graph it, and I'm going to show you what happens when they don't cross. Okay? So let's go ahead and graph equation number 1 over here real quick. We're going to do this in blue again. Has a y-intercept of 1, so I'm going to go ahead and draw a dot there, and it has a slope of positive 2 over 3. So I'm going to go up 2 and to the right 3. Up 2 and to the right 3. I'm going to go ahead and draw this line real quick, going this way like so, and it's going down over here like so. Yeah. Now we'll go ahead and move on to equation number 2. This is going to be, let's go ahead and do some math over here. I'm going to add the 2x over, so you end up with 3y is equal to 2x minus 6. Divide both sides by 3, and you end up with y is equal to 2 over 3x minus 2. Now, some of you might notice the slopes are exactly the same with each other, and some of you guys might remember from previous classes that if you have the same slope, the 2 lines are parallel to each other. I'm going to go ahead and graph this for you. It has a y-intercept of negative 2. It's down here. Count out the slope. Go up 2 and to the right 3. Up 2 and to the right 3. Go ahead and graph this guy. And if I keep doing that, you'll see that it flows at the same rate as the blue line. So these 2 lines will never cross each other, meaning they will never share a solution between the 2 of them. So if that happens and the 2 lines are parallel and they never cross, that pretty much means that there is no solution that will satisfy both equations at the same time. There are infinitely many solutions that will satisfy the blue one and infinitely many that will satisfy the red. But sadly, since the 2 lines don't cross, they do not share a single point. So a problem like this, where you have 2 lines that are parallel, whether it be a positive slope or a negative slope, this means that there is no solution that the 2 equations share with each other. Hope this was helpful for you guys. There's also another special case, and I'm going to leave this up to you to figure it out. What happens when the 2 lines happen to overlap with each other? I hope you guys the best of luck to figure this out and that this has helped you out. Look out for another video in the future.